Hello everyone, we are tutorial for Group 4. Today we are going to have AMA1501 group presentation. Here is our group member and the student ID. I'm Moran. I will introduce Monk 4 question 4a. Let's see the background. In a study of turnover rate of new employees after a one-year period, 150 new employees from various departments are selected randomly, and 29 of them are no longer employed after the one-year period. The question is, construct a 98% confidence interval for the turnover rate. Please look at the normal distribution table. For a 98% confidence interval, alpha is 0.02, so Z alpha 2 is 2.326. In fact, any Z in the interval 2.32 to 2.33. For example, 2.326. Next, let P be the sample proportion of employees who are no longer employed after the one-year period. Assume that random sample is drawn with replacement of infinite populations by central limit theorem, like this approximately. So, a 98% confidence interval for P is calculated as follows. The answer is 0.1183 to 0.2683. That's all. Thank you. Welcome to next group member.
Thank you, Moran. I'm Chang Lam Anna, and I'm going to explain the Mod 1 paper question 3A3. In this question, the sales amount of invoices of a certain company is normally distributed with a mean of $15,000 and a standard deviation of $5,000. If a random sample of 25 invoices is selected, what is the probability that the total sales amount of the sample is less than $256,000? First, we may let X be the sales amount of invoices of a certain company, and now we are looking at P of X1 plus X2 plus X25 to be less than 256,000. So this would equal to P of X1 plus X2 to X25 dividing by 25 less than 256,000 dividing by 25. On the left-hand side of this equation, we will have the X bar. So the equation now becomes to P of X bar less than 256,000 dividing by 25. According to the questions, we know that X is normally distributed with mu equals to 15,000 and sigma square equals to 5,000 square. Therefore, X bar will also follow normal distribution with mu equals to 15,000 and sigma squared dividing by n, which is equals to 5,000 squared dividing by 25. As a result, P of X bar less than 256,000 dividing by 25 is the same as P of Z less than 256,000 dividing by 25 minus 15,000 dividing by 5,000 dividing by the square root of 25. By solving this equation, we will get P of Z less than minus 4.76, and this is equal to P of Z greater than 4.76. Since Z is greater than 4.76, the probability that the total sales amount of the sample is less than $256,000 is approximately 0. And now I will pass the time to next group mate.
This part is about question 4C of Mock 3. In a random sample of 500 clerical employees from a large multinational company, 300 said they would like the company to adopt a flexible scheduling policy. The task is to construct a 90% confidence interval to estimate the population proportion of clerical employees favoring the flexible scheduling policy, and explain briefly how the confidence interval could be interpreted. To solve the question, first, let n be the size of sample, which is 500. Let x be the number of employees in the sample that favor the flexible scheduling policy. Then let p bar be the sample proportion given by x over n. Actually, it is 300 divided by 500 equals 0.6. In a similar way, let p be population proportion. In this case, we can calculate alpha given by the 90% confidence interval. 1 minus alpha is 0.9, so the value of alpha is 0.1. In this case, n times p bar is greater than 5, and n times 1 minus p bar is also greater than 5. Therefore, based on central limit theorem, p bar approximately follows normal distribution with mean p and variance denoted by p times 1 minus p divided by n. Note that p is unknown, so we estimate the population proportion using the sample proportion, which means replace p in the formula with p bar. We have known that alpha is 0.1 and thus alpha over 2 is 0.05. Read the alpha over 2 from the standard normal distribution table. 0.05 is between 0.0495 and 0.0505. Therefore, the value of z can be any number between 1.65 and 1.64. Here, we can simply let z alpha over 2 be 1.645. The 90% confidence interval on p is p bar plus minus d alpha over 2 times the square root of p bar times 1 minus p bar divided by n, which is 0.6 plus minus 1.645 times the square root of 0.6 times 0.4 divided by 500. Therefore, the 90% confidence interval on population proportion of clerical employees favoring the flexible scheduling policy is 0.5640 to 0.6360. It is 56.4% to 63.6%.
Hello everyone, I'm He Chongwei, one of the group member of Group 4. Now, here comes with my part. My question is from year 18 and 19, Sem 1Q1D. The question is about the sales manager of a hot meal delivery company is studying the delivery time of their orders. And the delivery times of a random sample of orders are listed below. We can see that there are different delivery times and number of orders in terms of minutes. And the question is asking to construct a 95% confident interval for the population proportion of orders with delivery time between 22 minutes and 38 minutes. And here comes with my solutions. Firstly, we have to find out x. X means the number of orders with delivery time between 22 minutes and 38 minutes. And it is equals to 31 times 25 minus 22 divided by 25 minus 20 plus 19 plus 11 times 38 minus 30 divided by 40 minus 30. And then we can get x equals to 46.4. Secondly, we have to find out n. N means the size of sample, which is equals to 10 plus 21 plus 31 plus 19 plus 11 plus 5 and then plus 3 equals to 100. Then we have to find out the sample proportion equals to x divided by n, which means 46.4 divided by 100 equals to 0.464. Then we can finally get the confidence interval on population proportion P, and by this formula. And it is equals to 0.464 plus or minus 1.96 times square root 0.464 times 1 minus 0.464, and then divided by 100 equals to 0.464 plus or minus 0.0977. Finally, we can get a 95% confidence interval for the population proportion of orders with delivery time between 22 minutes and 38 minutes equals to 0.3663, 0.5617. And here is the end of my part. Thank you.
Hi, I'm Kira from Group 4. This question is from Mod 2 question 1D. A financial analyst is interested in the percentage of revenue spent by computer software companies on research and development. A random sample of computer software companies is selected and the results are summarized in the following table. So, the question requires us to construct a 99% confidence interval for the mean percentage of revenue spent by all computer software companies on research and development. State your assumptions and approximation. With the data given by the questions, we can find out the class marks and the sample size. Therefore, we can calculate the mean, which is summation of fx divided by n. So the final result equals to 8.362%. Also, we can use this formula to calculate the standard deviation, which equals to 1.7370%. Next, according to the central limiting theorem, for n large enough, which means n larger than 30, then we can use these formulas: S bar plus and minus c value of alpha over 2 times sigma over square root of n. As the confidence interval is 99%, so alpha equals to 0.01 and alpha over 2 equals to 0.005. So the z value of 0.005 can be found in the table of standardized normal distributions, which is between 2.57 and 2.58. And we add these two numbers divided by 2, it equals to 2.575. Then a 99% confidence interval for meals is 8.362 plus and minus 2.575 times 1.7370 over square root of 50 equals to 8.362 plus and minus 0.6325. Therefore, the 99% confidence interval for the mean percentage of revenue spent by all computer software companies on research and development is 7.7295 and 8.9945. This is the end of our presentation. Thank you for your attention.